Earth grows darker. Scientists sound. Alarm over albedo collapse in Northern Hemisphere. In a startling revelation that reads like climate fiction but is entirely real, Earth is losing its shine, and scientists are racing to understand why. According to new analysis from NASA's CERES satellite program, our planet is reflecting less sunlight back into space, especially across the Northern Hemisphere. The effect is small but growing, and ominously asymmetric. A dimming planet, what the data reveals. For more than 2 decades, NASA's clouds and the Earth's radiant energy system, CERES, instruments have tracked Earth's albedo, the faint planetary glow generated when sunlight bounces off clouds, ice, snow, and land. Over the past 24 years, that glow is fading. The northern half of the globe is dimming faster than the southern, a trend that undermines prior assumptions about hemispheric balance in Earth's reflectivity. The old paradigm held that clouds acted as planetary equalizers, balancing bright and dark zones, but the new findings indicate a disturbing hemispheric asymmetry. The Northern Hemisphere is showing a sharper decline in reflectivity, while the Southern Hemisphere has held relatively steadier, or even brightened in localized stretches. To be clear, both hemispheres are dimming, but the North is dimming more rapidly, and that may have accelerating effects on climate change. The usual suspects, and something missing. Scientists point to 3 prime suspects. 1. Melting ice and snow. As glaciers and polar ice recede under warming, vast swaths of dark ocean or land are exposed, absorbing more sunlight instead of reflecting it. 2. Aerosol declines in the north. Cleaner air over northern lands and oceans means fewer small particles. Aerosols to seed clouds. Fewer clouds mean less sunlight sent back to space. 3. Unexpected brightening in the south. Large-scale natural events, like Australia's catastrophic 2019 to 2020 bushfires and Tonga's volcanic eruption, have injected sulfate aerosols into the Southern Hemisphere atmosphere, momentarily increasing cloud reflectivity and masking decline. Yet, even when accounting for shifting clouds, aerosols, and ice loss, the magnitude of the northern dimming remains only partially explained. We don't yet have a solid theoretical framework for this, says Norman Loeb, lead author and CERES principal investigator. Adding to the urgency, in 2023, Earth's albedo dropped to a record low, largely due to a stark decline in low-level clouds that normally act as reflective shields. This disappearance allowed additional solar energy to be absorbed, possibly driving up temperatures by approximately 0.2 to 0.3 degrees Celsius beyond what was expected. Why the asymmetry matters. If Earth were dimming evenly, the consequences would still be serious, but symmetric. But an uneven dimming introduces new uncertainties. A darker northern hemisphere upsets the balance of atmospheric and oceanic circulations, potentially shifting rainfall belts, jet streams, and monsoon patterns. Climate models built on the assumption of hemispheric reflection symmetry may no longer hold. Moreover, the dimming is not benign. It's a feedback loop. Less reflectivity means more solar absorption, which accelerates ice melt, which further darkens the planet, which warms further. Even more disturbing, the planet's energy imbalance has nearly doubled between 2005 and 2019, fueled by reduced clouds, melting ice, and increased greenhouse effect. A high-stakes watch in a funding drought. The need to monitor albedo trends has never been greater. Yet NASA warns that existing satellite instruments, Terra, Aqua, Aura, are aging and slated for decommissioning, leaving a looming data gap just when the stakes are highest. Climate scientists are calling for renewed investment in next-generation sensors to maintain continuity in albedo measurements. Without that, we risk losing sight of one of the planet's most sensitive thermometers. As Loeb puts it, we will continue to measure, we will continue to investigate, but time, funding, and data may not be on our side. What to watch next? Will new satellites fill the observational void and track albedo trends with improved resolution? Can modelers integrate the emerging hemispheric asymmetry to refine projections of heat, precipitation, and drought? Might the imbalance in reflectivity spark unexpected regional climate surprises? Monsoons shifting, storms intensifying, polar systems destabilizing? One thing is clear: the Earth is dimming, and not equally. The northern half is losing its luster fastest. What we once regarded as a subtle planetary flicker now seems like a drumbeat, warning us that our planet's mirror is cracking. Scientific vigilance has never mattered more.